Hi, I'm Richard Patterson, Product Manager for Scope Quarters and Oscilloscopes at Yokogawa Corporation of America. The DL350 Scope Quarter is our portable scope quarter solution. It has 2 slots for input modules, a touchscreen, and can be operated with a battery power, as you can see here. This means it's an ideal solution for portable testing or remote location testing. In addition, it has the capability to connect to a GPS receiver and record GPS data along with the other pieces of data you're recording in your system. To do this, you need the GPS receiver from Yokogawa that I have in my hands here. Once you plug it in, the GPS data recording feature records the following data: latitude, longitude, altitude, velocity, direction, and 2 status items, 3D fix and pulse per second, indicating if you have a good GPS signal lock. What is this useful for? This is useful for any location-based testing. For example, drive testing of vehicle systems around a neighborhood or a test track facility. The DL350 could record accelerometer data along with latitude and longitude and velocity data and evaluate how harshly a new car design vibrates at different sections of the test drive. Or a DL350 VE with CAN monitoring could record CAN messages correlated with location to troubleshoot during system validation. Now, let's walk through the steps to get it configured. First, plug the GPS unit into the GPS port on the side of the DL350. Next, enable GPS. Click the main menu, Analysis, then GPS. Now you can enable either GPS recording, GPS time sync, or both. Since I am recording in the eastern US, I am using a time difference of 5 hours from UTC for time sync. Time sync sets the system clock plus or minus 2 microseconds from GPS time. Once data is enabled, I can access the GPS options for all of the data items. GPS data takes the place of channel 6, the second digital input on the top right-hand side of the unit. Press Main Menu, then press Channel, and at the very bottom, you'll see GPS, and from here, you can access all of the different GPS data. Since we're working on a mobile test, we need to set the ranges to match the conditions of the test drive. 1 degree of latitude, for example, is about 69 miles or 111 kilometers. I used a popular mapping website to get the GPS coordinates at the start and end of my drive test. Notice that it's only about 0.03 degrees of range for my driving route, so these values could be very small. Also, unless you are going up and down a mountain, a wide range of altitude probably does not make sense. Last, our drive never exceeded 45 miles per hour. So, we should set the velocity from 0 kilometers per hour up to about 80 kilometers per hour. During a 15-minute drive, I used 1 minute per division timescale in order to get visible, usable data on my display. Here you can see the data captured during our drive test. I used an accelerometer plugged into the 701275 accelerometer input module at the same time as I was driving around and recording GPS data. The accelerometer signal shows you the vibration signal in red. I've got my velocity displayed in purple, and longitude and latitude are 2 shades of green. So using this, it's easy for me to zoom in on specific parts of the drive in order to find out what was going on with the vibration corresponding to what kind of velocity or acceleration I was experiencing during the drive test. So with the combination of analog and sensor input modules, along with GPS data such as latitude, longitude, and velocity, The DL350 makes a perfect drive test data acquisition system, and I can also record for a long period of time, accommodating drive tests up to several hours long. So that concludes my tutorial on using GPS with the DL350 scope quarter. Thank you very much, and please look for other videos from Yokogawa Test and Measurement.